Okay, let's jump right into this explainer. We're covering the NCP-MCI 7.5 to 8.1 Nutanix Volumes overview today. As an infrastructure admin, you're expected to know exactly how to expose storage externally to your bare metal applications. And well, that's exactly what we're going to map out for you. We'll take a nice, steady pace through this material so you really understand the architecture rather than just blindly memorizing it.
Here is our roadmap. We've got why Nutanix Volumes matters, a deep dive into connectivity methods, exam traps and edge cases, and finally, key facts to memorize.
All right, Part 1. Why Nutanix Volumes matters. Bridging the gap.
Let's define exactly what we're dealing with. Nutanix Volumes is a native scale-out block storage solution. It basically provides direct, block-level access to AOS storage, which, just as a quick refresher, is the Acropolis operating system running your entire cluster. It does this natively using the iSCSI protocol. Now, iSCSI stands for Internet Small Computer Systems Interface. It's totally the legacy industry-standard bedrock for presenting block storage over an IP network, and Nutanix has basically modernized it beautifully for hyper-converged infrastructure.
So think about bridging the gap. External, non-virtualized physical servers. Maybe you've got a massive bare metal Oracle database or a legacy Microsoft SQL server. They can connect seamlessly right to the hyper-converged cluster below. Volumes lets these external bare metal apps use cluster storage organized in a VG, or volume group. A volume group is really just a logical collection of virtual disks that get presented to the external network as available block devices. It's awesome because it lets your bare metal servers tap into that highly redundant, super fast, hyper-converged storage pool without you having to go out and buy, rack, or manage a completely separate traditional storage area network.
Moving right along to Section 2, Deep Dive into Connectivity Methods.
Okay, for the NCP-MCI exam, you absolutely must know the 3 supported connectivity methods for how AOS exposes this storage. Number 1, we've got iSCSI initiators natively integrated with volumes. Number 2 is iSCSI initiators combined with MPIO. Quick definition there, MPIO stands for multipath I/O. And number 3, we have a highly specialized ultra-high-performance option, NVMe-oF/TCP. Yeah, it's a mouthful. It stands for Non-Volatile Memory Express over Fabrics, specifically utilizing the transmission control protocol to transport data across your network.
So let's compare those two iSCSI methods, because you need to understand why Nutanix officially recommends native volumes over traditional MPI. On one hand, iSCSI with volumes uses a single data services IP address. This gives you native load balancing and path resiliency directly from the intelligence of the Nutanix cluster itself. On the other hand, with MPI, you are relying entirely on the client operating system's native multipathing capabilities to manage all of those paths. Now, don't get me wrong, MPI totally works, and it's fully supported if you have a legacy environment with super strict requirements. But it demands significantly more manual configuration on the client side. And more manual config? That means more overhead and a much higher chance of human error.
So why is the data services IP route the golden child here? Well, because it acts as a single, centralized, cluster-wide discovery portal. This is a massive operational advantage for us infrastructure admins. By using that data services IP, you get non-disruptive scaling. Just think about real-world storage management for a second. If you add a new node to your cluster to bump up capacity, using the volumes method means you don't have to go back and manually reconfigure every single client initiator with new target IPs. The client literally just keeps blindly talking to that one data services IP, and Nutanix handles all the heavy lifting and complex redirection on the back end. It seriously saves you from an operational nightmare.
Let's cement this with a concrete example. Imagine you're hooking up a physical Microsoft SQL server using that recommended iSCSI method. Step 1, you allocate your required storage capacity into a volume group. Step 2, you configure the iSCSI initiator on the physical SQL client OS to point directly to that single data services IP. And step 3, behind the scenes, with absolutely zero extra configuration from you, Nutanix automatically load balances those storage requests across the CVMs, or controller VMs, running throughout your cluster. This guarantees that no single CVM ever becomes a bottleneck. Your database just gets optimal, consistent, and highly available performance.
Let's try a second example. Say you have a workload that demands the absolute highest performance possible. Maybe a cutting-edge real-time analytics platform. Here, we ditch iSCSI and go with the ultra-fast NVMe-oF/TCP protocol. Step 1 is exactly the same, create a volume group. But step 2 is where things diverge. When you're setting this up in Prism Central, you explicitly select the NVMe-oF/TCP protocol from the drop-down menu instead of iSCSI. Then, step 3, you connect your external client.
This modern protocol is a total game changer. It drastically cuts down the CPU overhead that usually comes with traditional SCSI command translations, giving you a much more direct line of communication to the storage media. The result? Incredibly fast, predictably low latency block storage.
All right, moving into Section 3, Exam Traps and Edge Cases. Let's see how the test might try to trip you up.
Listen to this question very carefully. Can you use Nutanix Volumes to create an iSCSI data store for a VMware ESXi or Microsoft Hyper-V host? If you are reading a scenario question on the exam proposing this exact architecture to provide shared storage to a hypervisor, you really need to know the definitive answer.
The answer is never. Literally never. I really cannot stress this enough. You must never use volumes to present an iSCSI data store to an ESXi or Hyper-V host. It is explicitly 100% unsupported by Nutanix. No exceptions.
The official Nutanix Volumes guide puts this warning front and center for a reason. It flat out states not to use Nutanix Volumes to create an iSCSI data store to Hyper-V or ESXi hosts because the configuration is not supported. I want you to burn this into your brain so you don't fall for this classic exam trap. If a scenario requires you to attach a data store to ESXi, you should be utilizing NFS, not iSCSI, through Volumes. Trying to use Volumes that way completely bypasses Nutanix's native data locality and architectural advantages for virtualization. Just don't do it.
Okay, we are in the home stretch now. Section 4, Key Facts to Memorize.
10 seconds or less. Memorize that number. Because Nutanix Volumes provides high availability by design across the entire cluster, if a physical node suddenly fails or a CVM drops offline, the system automatically redirects storage access to surviving nodes. This failover process is incredibly fast and totally non-disruptive. The maximum initial delay your applications will experience during a failover event is roughly 10 seconds or less. That ensures your mission-critical databases stay online and happy.
Let's lock down these 4 specific rules. If you get these, you're going to nail the subtopic on the NCP-MCI 7.5 exam. 1. The volumes method utilizing the data services IP is always the recommended approach over traditional MPIO. 2. You have exactly 3 distinct connectivity methods available to you: Volumes iSCSI, MPIO iSCSI, and the high-performance NVMe-oF TCP. 3. A node failure results in a non-disruptive failover of 10 seconds or less. And 4. Our absolute golden rule: never use Volumes to create iSCSI data stores for Hyper-V or ESXi hosts.
So you now know exactly how to expose block storage externally using Nutanix Volumes. But consider this: high availability isn't just a software thing, it's a profound physical network challenge too. How will you design your physical top-of-rack switches and cabling redundancy to ensure that the data services IP remains truly resilient even if an entire switch goes down? It's something to think about. Best of luck on your certification exam, and keep questioning how these specific components fit into the big picture of your infrastructure design.